All right. Welcome to our presentation. We are Team 6. I'm Kaushik Marcella.
I'm John Reeder.
Brian Carey.
And we are going to be presenting our idea of Pete in the box. So just a little bit of background for the external judges here. We have certain requirements that we have to fulfill for this project and with respect to this class. So primarily this design idea has to be Purdue themed, and it has to have 2 or more motions within the mechanism. And we're going to have to use rapid prototyping for all the major components, and there's also a limit in the part size, cost, and the total volume of the parts. And in order to do all this, we need to hit it in one design iteration. So we had to simulate as much as possible in a virtual space, and that leaves a lot of uncertainty in our design. And starting, we had 3 main ideas. The first one was a Boilermaker fountain run, which involved the Boilermaker special, and we were going to have a track go around campus and activate a fountain once it hit every fountain. And then another idea was the world's largest drum, which we had a rolling car-like toy which would hit the drum as we moved. And then the last idea that we had was a Jack-in-the-Box. This is actually a video of the Jack-in-the-Box that I was going to play, but looks like it might not work right now. So basically what's happening over here is there's an infant and there's 2 parents, and essentially the mother is rotating the crank on the Jack-in-the-Box, and as she rotates the crank, music plays, and as the music is playing, the parents are very entertained, the toddler is very entertained, and then all of a sudden the Jack-in-the-Box pops up, scares the kid, starts crying a little bit, and then he starts laughing. This in turn entertains everybody. So we went back to the fundamental concept of a toy. What is a toy supposed to do? A toy is supposed to entertain the end user. So keeping that in mind and inspired by this video, we chose to go with the Jack-in-the-Box idea, but make it adaptable to the theme of Purdue Boilermakers. And we came up with Pete in the Box. So as you can see there, that's the box is Mackey Arena, and then Pete's going to pop out. And this toy actually, the way in which it entertains the user is by providing visual and audible stimulus to the user. And also there's a surprise factor in the end with Pete popping out. So we're going to be considering this as our target market, starting out with, because of the theme of Purdue Boilermakers, we're going to be looking at Purdue fans. Since there aren't too many of them left anymore, we're going to be concentrating more on the alumni, more specifically the parents and the infants or toddlers that we're going to be targeting. So with this particular design, we're going to be, the visual stimulus and the audible stimulus is going to be attracting our end users. And John is going to be explaining how the toy works and the mechanism that it is.
So, like he said, we've got this kind of overall Jack-in-the-Box concept. So this shows a representation of how the mechanism works. So there's a gear train on the outside, which is used to kind of crank the mechanism like the traditional Jack-in-the-Box. And then that actually releases the roof at some point, unknown to the user. And then once the roof is open far enough, that releases a platform, which allows Pete to pop up. So if you go to the next slide, help describe some more detail about this. So as you're rotating that gear train is actually going all the way up to the inside to slowly release the hatch hole and the roof together. And then, so then as that roof latch is being released, the mechanism over here pushes latches out of the way, which then allow the platform to pop up. And then just one more representation so you can kind of see all of it, what's happening on the inside. So, Brian.
So as far as our prototype goes, pretty much the entirety of it has been 3D printed. We used mostly basic design techniques for all the parts involved. primarily just extrusions, rotations, that sort of thing. The roof actually, we found when we looked closely at Mackey Arena, is not perfectly hemispherical. It is actually a series of straight lines across the top arranged in a sort of hemispherical pattern. So in reality, it looks as though it might be some kind of a 3D printed defect, but that's per design. We patterned bricks along the outside and used the spur gear tool to generate all the gears used on the outside. And then by far the most complicated part of the prototype would be our Pete figurine that you see on the inside. We primarily used the freestyle surface modeling for Pete in the Creo program, and using a bunch of primitive features, adding more control points to develop a relatively complicated mesh of over 1,000 control points to pull this mesh as we wanted it. We eventually wound up with a decent representation of Pete that wound up printing out pretty well. So here we have a side-by-side comparison of our prototype as we have it now and our CAD model as we had intended it to look like. I think we hit the mark relatively closely. Okay, we have some ideas, suggestions for improvements. At the moment, we have linear springs, just compression springs holding that are compressed as the roof is held together, and once the roof unlatches, it flings the roof apart. All right idea. Would have been much better if we could have gotten torsional springs attached at the actual hinge point in the back of the roof to supply a constant torque, so that once it releases, the torsional springs cause the roof to rotate instead of this flinging apart action. Unfortunately, early on in the design process, we found that pretty much every torsion spring, standard torsion spring that we could find, was vastly overpowered for what we needed here and would end up blowing the roof off. And so we, kind of cobbled together this compression spring just to do a sort of proof of concept idea. John, you had suggestions on clearances?
Yeah. So then, since this was the first semester with this rapid prototyping method, we didn't really know what we should aim for with clearances. So there was several clearances on pins, which I would improve on based on my experience this time around. And it induced a lot of error actually in trying to kind of sand down the pins after they had been printed, which could have been reduced by just spraying them with the proper clearance in the first place.
Yeah. Also, we could have had a lot more flexibility if we had the opportunity to use electronics for this. But then, unfortunately, none of us knew how to code on Arduino or LabVIEW, and within the given time frame, it wasn't feasible. But if we did have motors, we'd have a better control of how the unlatching of the roof and even possibly Purdue Pete coming up. And in terms of concept, we could improve a lot in terms of the visual and audible feedback that we provide to the end user. We could have any sort of lights or even the music that plays around. We're thinking of having the fight song from Purdue play as you use the crank. And then also the longer gear train actually relates to the market potential of this toy. Basically, this toy, the gear train is a representative of any sort of puzzle that could be solved in order to pop Purdue Pete up. And we can vary the complexity of this puzzle. For example, this gear train could be made much larger, and all it does is affect our the target market. So the simpler it is, the younger the age group, the more complex it is, the older the kids that we're trying to target. So, and also this could be very expandable in terms of market, because the Mackey Arena is just a representative of any sort of iconic building for any sports team. So if you had to adapt this for the Chicago Bulls, for example, you can adapt Mackey Arena to be the United Center, and then Purdue Pete could be Benny the Bull. So this could be adapted to any given sports team, or even SpongeBob, Pineapple, SpongeBob, anything.
One important feature that I think we didn't really mention earlier in the report is that all of these gears are actually removable. They nest in posts that are set in the base, so the crank and the 4 gears on the outside can all be pulled out, and so that adds a bit of more playability to it because it represents a puzzle that you have to solve before you can actually open Mackie. When it's in its latch state, the only way to open it is assemble the gear train and turn the crank, and then release Pete. So we have a video representation, or a video showing the unlatching mechanism. Unfortunately, as it all turned out, we could not get the mechanism to work all the way from start to finish, so we have sort of two-stage showing the gear train working, and then the gear train causing the unlatching and the spring knocking the roof apart. Now we can do a live demonstration of the and then we can do a live demonstration now of the platform coming up.
So unfortunately there's a bit of a final assembly error, so we can't do a full, just take one half of the roof off.
Due to a tragic glue spill, the right half of the roof is frozen in place, and so we have to trigger the right side manually. Okay. Go on 3, or are we going 2? The cam is stuck in place. All right, so that doesn't work, but right. So since the roof is this hinge is stuck in place, one of the lever arms that was intended to do the unlatching is preventing the platform from coming up. So unfortunately, that's it. So any questions?
Can you talk a bit about modularity? How you can replace it with any what about your design? Maybe not this prototype, but what would you do with your design to make sure that you use it as a limited or the cosmetic changes that would
Yeah, so in general, the mechanism was pretty much just designed, and then the shell was placed around it. So it would pretty much just be changing kind of the outside configuration.
All the features on this are pretty much superficial. You see the bricks, the windows, and then the pillars are the 3 main things that make up Mackie. Other than this, it's just a cylinder. So with just a cylinder, we'll have a lot more flexibility because the features are not an integral part of this.
and the order of assembly, how does it work? Is this a cylinder single class?
Yeah, so the major mounting components are all part of the base housing, and then all of the gear train can be assembled into that, essentially through lots of pins and but essentially there's a lot of groups on the pins to allow for those to be simply slid together.
And the mascot could be removed.